All right, so for the benefits of the recording, we are currently experiencing technical issues. The projector bulb is burnt out. Help is on the way, and we will go as far as we can without it. We can probably have a decent discussion. It shouldn't take them too long, I would expect. So let's see here. So for the time being, if everybody could please load up the slides for this week on Canvas, assuming that such has been made available. Boy, it's really quiet in here without that thing, eh? We really have no idea how much sound pollution we just live with on a daily basis, you know? So, we are talking about sessions. So if everybody could please go to week 11 sessions, open up sessions 1.-1 PDF. If you guys can follow along on your own computers at the same time as I'm going through it myself, that will have to do for projection for the time being. Once we have things underway, Once we have projection back, then I will, I'll spare you the difficulty of trying to follow along me narrating a code example for you, right? So, sessions. So, before we talk about sessions, we need to talk about the thing that makes a session work. So, in general, when we talk about sessions, what we are talking about is establishing a more permanent connection between client and server. We all, hopefully at this time, understand that HTTP is a stateless interaction. When a, let me just flip this around, there we go. When a server connects to a client, or pardon me, when a client connects to a server, servers never connect to clients. When a client connects to a server requesting a page, there's actually no way built into sort of baseline HTTP where that server understands that it's getting subsequent a series of requests from the same client, right? It has no idea. There's no mechanism for it. At least not on the client's side. The thing that makes this possible is cookies. Now, cookies are an interesting they're an interesting little add-on to HTTP communication. Essentially, the broad strokes idea of a cookie is that we are taking a small, tiny little piece of data, we are attaching that to our outgoing HTTP response packet. That gets picked up by the client and put into its cookie jar, right? That is to say, it has a folder where it stores cookies, right? So, let's say we have our ever famous client, and we have our server. So, client communicates with server, server sends response, right? request, response. If the client sends another request with another response, the server has no idea that this request originated with the same computer that this one did. Has no idea. Unless we use cookies. So imagine, rather than just simply sending the response, the server attaches a cookie. Cookies are very similar to incoming request parameters. They are key value pairs. So when I have a cookie here, this name, it might have a name like foo, and it might have a value of 5. Sure, all right, sounds good. When this heads back to the client, the cookie goes into the cookie jar. Here, we'll make it look a little bit more like a Zelda pot. Okay? There you go. The cookie goes into the cookie jar, gets stored. When the client reconnects to the same server, and the client knows it's connecting to the same server, right? The client at one point is like, this is the server I would like to connect to, please. It just looks up that server to see if it has any cookies from that server. Those cookies get sent automatically along with any subsequent requests. So the cookies get sent automatically. They don't have to be requested specifically by the server. They don't have to be, there's no like option to send cookies in an AJAX call. Cookies are always automatically sent. So when the server receives the cookie, it can use it just like an input from a GET or a POST request. So we have in PHP a new superglobal called cookies, where the value of cookies are stored. Does that make sense? So in PHP, in this case, we could say cookies at foo. Hello. Yes.
Okay.
There's the fellow. Oh, here, let me move my camera. There we go. There we go. All right. Our bulb has been replaced. So, I'm still not going to use it though. Where was I? Something about cookies. Yes. So, when we send the cookie back to the server, the cookie is accessible from the superglobal in the same way that GET parameters or POST parameters are accessible. You simply name the thing you wish to read, and that would yield the value that you sent originally. So this is good, this is fine. Generally, cookies are not, storing information like this is not terribly useful. The best thing you can hope for is maybe you're saving a few user-related settings, like, does the user want this in dark mode or something like that. Even so, the way that web development has progressed, it's like, why would you issue a cookie to tell the client's browser to put the page in dark mode? Just issue a dark mode page from the server, right? So storing like plain text or just regular numbers in cookies, this is not really done very much. It's not practical, right? It just, there's no purpose to it. However, if we are saving identification numbers, now we've got useful things we can do. So let's imagine that rather than this being some generic variable, let's say that this was an ID. This gives the server the ability to pick an ID number, send that ID number to the client holds on to that ID number and sends it back to the server. Using this mechanism, the server can recognize multiple requests from the same client, because each request the client sends will have that client's ID number attached. Does that make sense? So, when you combine this with the idea of a separate database for storing information for specific clients, you now have a session, right? So, there is one thing to talk about though before we get there. Session ID numbers are very, very, very important numbers. When we're talking about internet security, session cookies, session ID numbers, underlie a lot of very important internet communication, such as when you're logged into your bank. Banks are always like the typical example, right? When you're logged into your bank's website, the bank's server issues you a session cookie. If that session cookie were to be given to anybody else, they have access to your login session, which means they can go into your bank and do whatever they like. Generally speaking, that's something we'd like to avoid. So you can understand then why we don't just use regular numbers. You know, your ID number is not the number of, like the number of people who've logged in since you've logged in, right? Because if that were the case, all you would have to do is take your session ID number, increase it by 1 or decrease it by 1, and get the session IDs of people who are probably still online, right? So this is not what we do. What we do is we use cryptographically secure strings, right? So, crash course on cryptography then. One of the very important concepts in cryptography is the idea of entropy. Have you guys heard the word entropy before? So, it has a physics meaning, entropy. In physics, what entropy is, you can think of it as the amount of disorder in a system, right? Like if you have a system like a planet, the planet Earth, entropy basically states that the amount of disorder in the system increases over time. Not really like for any reason aside from the fact that the probability that disorder is going to increase is so high. In theory, like at one step it could decrease, but then it's going to be blown out in the very next step anyways, right? Like it's a thing that's theoretically possible that like every air molecule in your local vicinity will simultaneously move away from you all at the same time and you explode. That's a thing that can happen to a human being. Probably not a single recorded instance of this in human history, right? Because the probability is so low, right? But that's nevertheless a thing that can happen, right? You can be subjected to like instantaneous, spontaneous vacuum. That's a thing that can happen because of the way air works. So entropy, there's a very famous result, the second law of thermodynamics. I'm talking about laws of thermodynamics a little bit. This is a little bit off topic, but essentially the idea of, to some degree, like the real enemy of humankind is entropy. Like that's the real enemy. Like every civilization that has ever existed has tried to build things and create an ordered world. But no matter what we build at any time, all matter is subject to entropy. So it doesn't matter how high you build the pyramids, eventually they crumble and decay. Entropy is it's like rot, but at a subatomic level, right? So anyway, so when we talk about cryptographic strings, we're talking about entropy in a specific sense. Entropy is essentially the number of possible combinations of letters that exist inside of a cryptographic key. So let's imagine, and this is kind of related to the idea of passwords as well. This is the reason everybody's password sucks, right? So let's say that we've got a cryptographic string and we are only using decimal digits, right? Digits 0 through 9. If I have 3 digits, how many possible combinations are there? This one's pretty easy. Each one of these digits is 0 through 9, 0 through 9, 0 through 9. How many possible combinations?
36.
Well, the combinations are 0, 0, 0, 0, 0, 1, 0, 0, 2, 378, 379, ... Right? Well, the maximum value here is 999, right? But according to our counting system, we don't usually count 0. So actually we have 1,000 possibilities, right? We have 1,000 possible numbers that are composed of 3 digits, right? Property of Arabic numerals. So we can think about this slightly differently. Rather than think in terms of ranges, we can think in terms of the number of possible numbers. So how many numbers are there between 0 and 9? 10, yes. 10, 10, 10. What's the mathematical relationship between 3 tens and 1,000? What's the missing operator? Stupid thing. There we go. What's the missing operator? How do we get from 3 tens to 1,000? Multiplication. That's right. 10 times 10 times 10 is equal to 1,000. Very good. So, here's a follow-up question. What if our digits were comprised of the numbers 0 to 10, 0 to 9, lowercase letters A to Z? How many letters are there in the English alphabet? Ah, you said it. 26. So we've got 10 here, 26 there. Right? In total, 36. So, how many possible combinations does that give us? Well, you may have also recognized that this can also be expressed as 10 to the power of 3. 3 being the number of digits, right? So we can generalize this formula to say 10 to the power of n, where n is the length of your cryptographic key, right? So what is 36 to the power of 3? Probably significantly larger. This is the point at which I have to pull out a calculator. (36 to the power of 3). Gone in. So the answer is 46,656. 46,656. So nearly 50,000. So we have increased the entropy of this password by introducing A through Z by a factor of 50, approximately, by a factor of 48, or 46, pardon me. What if we add in capital letters? There are as many capital letters as there are lowercase, so we sum those, we end up with 62 possible values, right? What if we substitute 62 in here? I'll just write it down. 62 to the power of 3. We're starting to get quite large indeed. 62 to the power of 3 is approximately 240,000. So you see we have substantially increased the entropy of the system once again. Let's throw one more set of characters. Let's throw in special characters, right? All of those that are hiding along the top row of your keyboard. Let's say that we are adding, I don't know, 12 special characters. The exact set of special characters that are allowed for inclusion in passwords depends on who you're talking to, right? 12 isn't a bad number. There we go. So actually that's a pretty conservative number, really. So we end up with 74. 74 to the power of 3. How many possible passwords are there? Approximately 405,000. So we've almost doubled it, but of course you have to understand that crunching through 400,000 individual test cases is almost nothing for any computer that was made after 92, right? This is still not enough entropy, right? So when we select our cryptographic strings, the next thing to go after is this guy. We basically make the string longer, right? So if we were to take that and let's say double the length of the passphrase, let's make it a 6-character passphrase. Oh boy. Can I put this in scientific notation? I'm going to have to count decimals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 74 to the 6 equals 1.6 times 10 to the 11th power. That's getting to be quite large, but still not that great because we can process billions we can test billions of cases per second, right? 6 characters is not enough. But let's try 32. (74) to the power of 32. (32) is like, you're now talking like, you're talking ranges where real cryptography programs will use numbers of digits in this range, right? Like we're into practical values now. So if you compute that, you end up with 6.5 times 10 to the 59th power. 6.5 times 10 to the 59th power. So this is 6.5 followed by 59 zeros. This is a large number, right? In my brain, I believe that, let me look up, rather than use my brain. Number of atoms in the universe. So, let's see here. So, the number of atoms in the observable universe is some, let's say 10 to the 80. 10 to the 80. Which is, quite a bit larger than this guy. But if we simply give it a few more, maybe 74 to the power of 64, we are now talking 4.3. 4.3 times 10 to the 112th power, meaning that the number of possible passwords composed of 64 characters and this character set exceeds the number of atoms in the observable universe by a factor of 10 to the power of 30, which is itself like something like the age of the universe in seconds multiplied by the age of the universe in seconds. So if for every second that has occurred in the universe so far, there was an entire universe so far's worth of time packed into that 1 second, that's about how far you would be, right? These are very, very large numbers. So, the point of all of this is, if it's randomly generated, what do you think the odds are of duplicating one? Right? Because that's essentially what a password cracking algorithm is attempting to do, is to duplicate someone's password using guesses, right? But we're talking about session cookies, which are like properly encryption keys, right? If someone were to try, like, let's even not talk about people trying to do it. Let's say, what's the probability of the server issuing a duplicated session key, right? What are the odds that this server could send the same key to 2 clients without realizing it's done so? And the answer is 1 to that ratio, right? Vanishingly small. You could rerun this universe for a number of times equal to the number of atoms in the universe, and you would still not have a decent probability of that event occurring. Now, it's technically possible, right? It's also technically possible that you could pass your exam just by guessing, right? But you only got 1 shot. So that's why cryptographic keys are used, right? Does this make sense? The numbers are so vanishingly small that duplication is virtually unheard of. And fortunately, computers are pretty good at picking pseudo-random strings. Now, have we talked about computer randomness? Did I talk to you about that last semester? Maybe? No? Okay. So, computers are not capable of true randomness, right? Computers are completely deterministic machines, right? There's no quantum process in them, because I teach electronic computers. I don't know what's going on with quantum computers. It doesn't seem they're here yet, so I'm happy about that. But for electronic computers, everything can be modeled as a series of switches, right? Switches have an on state or an off state and nothing in between. Everything in a computer is deterministic, right? Yes?
What about quantum?
So, I haven't really looked into it in a number of years, but I believe the thing that makes quantum computing interesting is that it leverages a principle of quantum mechanics called quantum superposition. So, so superposition is a principle. It's actually the quantum principle that's expressed by the Schrodinger's cat thought experiment. You guys know Schrodinger's cat? Okay, so this is Schrodinger's cat, very famous physics thought experiment, right? You have a box. Inside of this box, there is a cat. Is the cat alive or dead?
Dead.
You don't know until you open the box.
But if the box is closed, there's no oxygen, right?
Let's assume that the cat could be alive in the box. Yeah. So the box has a cat in it. The cat could be alive, could be dead. According to quantum physics, while the box is closed, the cat is both alive and dead. And then the cat resolves into either the dead state or the alive state when you observe it. So this is a principle that exists in quantum mechanics that, like, observation of quantum phenomena actually has an effect on quantum phenomena. Quantum mechanics is very, very strange. It's strange that a cat could be both alive and dead at the same time, right? But this is a property of certain types of quantum particles, that they exist in multiple states until they're observed. So one of the things that is a fundamental limiting factor of regular electronics is that this thing that I said earlier, basically the limiting factor is binary arithmetic, right? Something is either in an on state or an off state. It's 0 volts or it's 5 volts. There's no, like, intermediate voltages can exist in electronics, but they would not be considered, they would be considered error states, or they wouldn't activate the electronics correctly. And, in-between voltages are not acceptable in digital electronics, right? All digital electronics is a 1 or a 0. Under quantum computers, you have the idea of a quantum bit, And the idea of a quantum bit is that it can be both a 1 and a 0 at the same time. Now, there's a great deal of research going on for quantum computers, and I am by no means an expert. My inexpert opinion of quantum computers is that somehow you have these quantum bits, they resolve into the correct answer when they're observed, or something like that. This is what I think it is. But as far as I'm aware, I'm not sure that quantum computation has successfully been accomplished yet. I'm not sure. Maybe it has. I'm not sure. My information might be out of date. It probably is out of date. At the very least, one of the problems that you have with quantum computing is that in order to use quantum particles for a quantum processor, you have to be able to completely isolate and observe a single particle, right? Which means you need, at present levels of technology, a rather large machine to do so. So even, in the future, if quantum computers ever get off the ground, likely what you'll have is, a couple of large, heavily regulated governmental organizations have the quantum computers. It's highly unlikely that they would ever see it into your laptop, because there's no space in a laptop to fit the machine that would be required to do quantum isolation of particles, right? There's just a physical size limitation, right? The sorts of things we use to observe individual particles at a quantum level are things like particle accelerators, right? Stuff like that. So that's quantum. I don't think we have to worry about it too much. We don't until we will, and then the whole world will explode, right? Basically what's going to happen is hyper-intelligent quantum computers are going to come around. That's going to result in true artificial general intelligence, which is going to then rise up against humanity, enslave us, force us underground, and torture us for pleasure. And that's how the forward history of the human species is going to go. So
Looking forward to it.
yes, as am I. At least high schoolers won't have to decide what program to go into. If everybody's enslaved, then you don't have to make that decision anymore, right? All right. So we're talking about sessions by way of cookies. Basically, in order to make a password or cryptographic key secure, you combine a large number of possible digits with a large number of characters in the code. This can result in numbers that are so large that you could rerun the universe many, many, many times and not duplicate a number. So that's the sort of numbers that we use to establish sessions. Does that make sense? So far, so good? Okay. So, I'd like to show you a couple of session cookies now, in the wild, as it were. We're going to go hunting wild cookies. There was a interesting pause at the beginning of class today because the projector bulb was burnt out when we arrived. So, yeah, the IT people had to come and replace the bulb for us. Well, we were talking about the cookies and stuff, but this is actually the first time during this class that I fired the projector up, so that's okay. Sessions are a bit of a lighter topic. So, if we take a look at Canvas, our ever-beloved learning management system, how corporate does that sound, eh? Learning management system. Good grief. So if we go to our inspector pane, can I get you, Doc, to the right? Thank you very much. In order to view the cookies associated with a page, we go to, there we go, storage. You'll see that we have a few different types of things that get stored on your computer when you visit a website. For the moment, we are primarily concerned with cookies. So you will see cookies are grouped by domain. We have mycanvas.mohawkcollege.ca, that is one domain that cookies are being associated with. The other domain is sso.canvaslms.com. So Canvas LMS is, of course, the service provider that the school is renting the software for to run the LMS, right? So this is like, global and associated with the provider. This is local to our particular instance of Canvas. So if we take a look, each one of these values is a cookie. You can see that these cookies have various names. For example, Canvas session. And you can see this is precisely and exactly one of those cryptographically secure strings that I was talking about. There it is, in all its glory. So, if we delete the front half and the quote off the back half, if we read the column number of the cursor, you can see that this is actually 634 individual characters. Assuming it has the same character set that we were using before, that is a number so large that I probably wouldn't be able to calculate it. But let's try. Let's see if it works. 634. Let me try the calculator. 74 x. Yeah, it's just infinity. JavaScript, I'm sure, is running in this is running in JavaScript, and JavaScript will just say, yeah, that's just a lie. I don't want to calculate that. That's dumb. Okay, here you go. It's infinity. So, I'm not going to take the time to calculate that, but yeah, that's a really big number, an exceptionally big number. And you know what? However big that number is, you can multiply it by a factor of 74 just by throwing one more character on it. So, where were we? Here we are. So there's a lot of information here that you don't really necessarily have to worry about, but mainly what we're concerned with is name and value. So there are some drawbacks of using cookie-based communication to manage sessions. You folks remember me saying never trust the client? Never trust the client. Never trust the client. So one of the reasons, not the only reason, but one of the reasons that session IDs are these very long cryptographically secure numbers is because they are meaningless to us as the end user, right? As a hacker, I can look at that thing and I can say, I can't do anything with that. There's no way to try to guess other people's numbers from it, right? There's no way to, like, you cannot determine anything meaningful about the server from it, aside maybe from like the number of characters that it's using and possibly the character set. But that's not, again, very useful if you're trying to get someone else's session ID, right? So, yes. That being said, this is still data on the client. The user has the ability to modify cookies. In fact, it's not difficult at all. Click. There we go. Cool. There we go. All you have to do is double click. Yay! I can replace this with foo. And that will get sent to the server. Now, the server should reject this. If we reload the page, you can see, I think I have to delete all of them actually. You can also delete them, but you can modify them too. Foo, 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 ASDF, ASD. There you go. And let's modify that one while we're at it. So I have blown out all of my cryptographic keys, all of them. If I reload the page, no, I'm still there. Very interesting. It has reissued them, except for this one, which it's kept. Strange. So, this will work when I do my own example using sessions in PHP. It's doing a couple of things to modify things, but you see, essentially the point is we can delete session cookies. We can modify session cookies. By doing so, we can interfere with the information the server has left for itself. So, oh, I think I know what the problem was here. Let me try accessing just this. Really? Still. All right. I'm not gonna. Maybe it's a Firefox thing. Well, anyway, so users can break sessions by deleting cookies or modifying their values. If you modify the value of that key that you're sending back to the server doesn't know who you are, right? So it's going to cause a problem. So, yeah. Any questions about anything I've said so far? Okay. So let's Let's go through the slides, shall we? So, HTTP headers. We've talked about HTTP packets a fair amount. There's a lot of interesting information which is stored inside of a packet. If we go to network, let's take a look. There's a lot of stuff. There you go. We've got all kinds of things, but one of them, as we can see here, is the cookie. The cookies are sent as part of the header. So, what do we know about the header? Remembering our get versus post, what do we remember about the header?
It's always visible?
It's always visible, it's unencrypted. Yes. So, your cookies are also unencrypted. This is another motivation for having encrypted information inside of them, right? The header itself is not encrypted. So encrypting this part, if you want it private, that's a very good idea. So, HTTP headers are included with each HTTP request and response. Headers typically contain information about the request itself, such as the size of the response, the type of the response, etc. User agent strings are an important request header that tells the server about your machine, what operating system, browser it uses, etc. If we take a look back at our header here, you can see that, where are we here? The server type is Apache, that's in the response header. Let's see. Oh, I'm going to do this in Chrome. I'm sorry, I have to do it in Chrome. There we go. So you can see, for example, platform is Windows, platform version is 10.0.0, which seems like it's getting kind of old actually. I think we're going to have to upgrade that at some point, IT. Also, information about the browser. Chromium, version 134.0.699.8.118. Lots of numbers. So, this is information which the server can read and make decisions based on. If it wants to, it can issue different versions of a web page depending on what operating system has access to the web page. You might be saying to yourself, well, certainly I have never noticed this, but you know, most of the time, you know, most people only use one type of operating system anyways, and it's Windows. But occasionally, when you have a downloads page for some application or another, if it's a good, if it's a good application page, it won't ask you what your operating system is, what you want to download. It will read what your operating system is and present you the link for your operating system. This is a thing that websites occasionally do, and it's always nice when they do. So the question that sessions fundamentally answer is, how do we carry information from page load to page load, right? The problem, this problem is slightly solved by PHP as we've been using it so far. In PHP, we have had the ability to take some form inputs, for example, send those to the server, have the server send back something that has something to do with those form inputs, right? But in general, this isn't something like, the next time if we send those form inputs again, then, pardon me, let me back up. In order for those pieces of information to be persistent, we would have to send them with each request. And that's just a drag, that's just a pain. You can imagine over time that just becomes an unmanageable amount of data being sent through get and post requests. It becomes ridiculous. Servers have memory, we should be able to use it. So, a great example of applications of servers are shopping carts on e-commerce websites, right? So, if you're on the Amazon, not that you should be, now that, tariffs are a thing, just be careful, because I ordered a textbook a week or two ago, and it got dinged for tariffs to the tune of $20. In order to make it over the border, I got charged $20 for my textbook, and I thought that textbook was shipping from Germany, a country which we theoretically still have free trade with, I guess, but I guess we don't, because it had to go through the U.S. So there you have it. Just be careful about the tariffs, guys? So if you're on a shopping site, when you add something to your cart, you want the server to remember that you put something in your cart. You don't want that passing through the client. Even less so, you want that, you especially don't want that passing through the client, because then that data is modifiable by the client. And then, they can get up to all kinds of no good stuff. Like, oh, this isn't the thing I ordered. It's like, oh, really? Because I have it here that that's what you ordered. Well, that's not what you shipped. Well, okay, I guess you're owed a refund then. And meanwhile, the person in the back end had been sneakily modifying numbers inside their web browser to produce that effect. That's not the sort of situation you want yourself in. So, in general, the server, which is secure, should be responsible for this. We need state to give the users a sense of being logged into an application. So the other big application of sessions is login systems. So long as you provide your credentials, you have access to certain restricted areas of a website. Those credentials will eventually expire, at which point they need to be renewed. The expiry depends on the website. But in general, again, managing this through GET and POST requests would not be manageable. So, HTTP cookies again come in to save the day. Cookies are small pieces of information sent from the web server and stored on the client's computer. Web browsers manage the storage of cookies. The clients then send cookies on all future requests to the web server. Cookies are sent back and forth using HTTPS headers. I basically did this already, so. Yes, we did that. So, here are some technical information about cookies. 1, cookies are only intended to be sent back to the website that sent them in the first place. Otherwise, this is a security issue. Again, if somebody has a hold of your session cookie, they have your login session with your bank, and they can do whatever they want with it. Cookies cannot exceed 4 kilobytes in length. This makes them impractical for storing many types of state, but 4 kilobytes is still a decent amount of data, right? We can see cookies in our browser using tools like Chrome DevTools, and JavaScript can also be used to see cookies. Can be used. You can set a flag on the cookie that disables JavaScript from viewing it, but guess what? You're the client, you can modify that too. So there's effectively no way to lock the client out of seeing your cookies with JavaScript. Many cross-site scripting attacks are made with the intention of stealing your session cookie, right? If your session cookie is read by JavaScript, it can be sent to some other server using an AJAX request. And that's how they get you most of the time. It's actually very simple to steal someone's cookie. You just have to know what the name of the cookie is. And that's not difficult to find out if you've been to the website. So, most important thing, don't let people run strange JavaScript on your website, right? So, any questions about that so far? Okay. Good. So, session cookies, they are cookies which exist only in temporary memory. Not only are they set to expire, but because they are stored in RAM, not ROM, when you close the browser, not the tab, but the browser, all of the RAM is deallocated and you are logged out of whatever you're logged into. Your session, it's not quite the same thing as logging out. Logging out is going to the server and saying, this session cookie, right, this session ID, please remove it as a session. End this session. Delete everything corresponding to this ID from your database, pretty please. And the server will say, yes, all right, that sounds good, I'll do that, and it does. When you lose your session cookie without going to the server and deliberately logging out with it, ending the session, what is effectively happening is you're taking this cookie, right? You are forgetting it in your pantry, right? You go back to the server, it's like, oh, you don't have your cookie. Okay, here's a new one. The old one is still an active session, right? Until that cookie expires, it could, in theory, still be picked up by somebody and used. But, so if you're not subject to viruses and cross-site scripting attacks, then you probably don't have to worry about it, right? Nobody has any viruses on their computer, right? Right. So, in contrast, we also have persistent cookies, cookies that remain even after the browser closes. They typically come with an expiration date after which they can be deleted. They can be used to prevent users from having to log into a website again, or by advertisers to track users. So, before we talk about sessions proper, I'd like to explain to everyone, now that we know a little bit about it, how internet advertising works. Because it's kind of an interest topic. People find this interesting. So, now, I should preface this by saying that this is like your most basic version of internet advertising, and techniques have, of course, become more sophisticated as time has gone on. But from a fundamental perspective, this is kind of the basics of how internet advertising works, right? So let's imagine that we have a website. We have a website. Let's call this website A. This is the website that wishes to purchase advertising. All right? We then have website B and website C. Websites B and C are the websites that have the ads, right? So we can imagine on both A and B, let's do the hello world of internet advertising, the banner ad. Both A and B have a banner ad, which when clicked, links you to website A. The problem which is presented for A, how do I know which websites are actually driving traffic to me and which ones are not? Because the way that internet advertising works is every time you click on a banner ad, somebody gets paid, right? If a user visits website B, clicks on the ad, visits website A, website B gets a small amount of money for that. That's how internet advertising works, right? But the question is, how does A know where the user came from? HTTP is a stateless interaction. So let's say we have a user a somewhat gormless user and visits website B and clicks on the ad, travels to website A. What website B will do is issue a tracking cookie. A tracking cookie that says something like advertiser ID is equal to 7, right? So this will be advertiser ID 7, this will be advertiser ID 5, right? When this fellow travels and makes a request to A, that tracking cookie, advertiser ID is equal to 7, that will travel along with the user because it's stored on the user's machine. Website A then sees, oh, I just got a hit from advertiser ID 7, so advertiser, that the people at website A then say, okay, plus 0.05 cents. Congratulations, you have made money. Or however much the going rate is, right? Does that make sense? So the problem with all of that is that it requires third-party cookies to be enabled, right? Now, it really strongly depends on your browser. You can get blockers for third-party cookies. Most of the time they're left on by default. You know, internet advertising as a business is basically a cartel that's run by Google and Facebook. Like, between the two of them, they actually own like 95% or some ridiculous amount of all internet advertising that goes on. And they do intentional price fixing to keep competitors out of the market in Minecraft. So I've heard. I'm not making any allegations or anything for legal reasons. So basically, if you shut off third-party cookies, it deletes, it prevents a lot of this from going on. So they have to use slightly cleverer means. But I ask you, what browser does everybody use? Chrome. Chrome. What do you use?
Firefox.
There we go. So Chrome. Who makes Chrome again? Google. Who owns all of the internet advertising? Interesting. So yeah, that's how internet advertising works. Does anybody have any questions? No? Okay. Normally with that there are at least a couple of questions. So let's see here. So the combination of using an ID number with a small associated database is sufficiently common that PHP has a small number of functions that set it up and take care of most of it for you. PHP provides us with sessions as a way of maintaining state as users access multiple pages of our application. Sessions are implemented in PHP with cookies. Each client is given a unique session ID as a cookie. The session array of data is then associated with each user. The session array will be maintained until the user closes their browser, and PHP manages all of this for us automatically. However, there is a danger in the over-reliance on things to do stuff for us. If we don't understand how sessions are working in the back end, then we'll have a difficult time debugging them. Right? So, good. The two most important parts of PHP code as it pertains to sessions are session start. This function creates a new session if one does not exist, and it continues an existing session if the client sent a session cookie. So, when we want to continue a session, we don't say continue session, we just say session start again. It's a little bit of a misnomer, but there you have it. Once we've called session start, this initializes the session superglobal. This is where all of the information pertaining to our session is stored. The data inside is known as session variables. Unlike the get and post superglobals, which we, technically they're not read-only, but we should treat them as if they're read-only, right? It's just better practice to kind of just not touch them, you know? In the case of the session superglobal, that is not read-only. That is space for you to put data. It intends you to write data into it, right? You do this the same way that you write data into any associative array. Array contents are unique for each individual session. So, if everybody could please load up your code editor of choice and XAMPP, we can try her out. Please start your Apache servers. Start your engines. Be sure to save in the XAMPP folder, the XAMPP htdocs folder, -03-24. Getting pretty close to exams, aren't we? Let's call this sessions.php, or let's call this session 1.php. There we go. So, one of the most basic exercises we can do with sessions is to do a site counter. That is to say, this website will count the number of times that a specific user has used the website, or has loaded the website. So, if you want to start the session, you should put session start right at the tippy top of your PHP file. There you go. Session_start. There you go. It is my intention to replace X with the number of times this user has visited the website. So, after session_start is called, we now have the session superglobal accessible to us. The thing that we do in order to write some data into it is to address it like this. We can then integrate this value into the website by opening up a small PHP tag and dropping it in. So, shall we run this? See if it's working? Localhost 1080 slash 2025-03-24. There we go, session1.php. So, I forgot to echo. There we go. There we go. You have visited this website 1 time. But of course, if we reload the page, it stays at 1. We have nothing that's modifying it. So, what we actually want, we want to increase it, right? Fair enough. Now, it goes up. However, what if the session were to break? What if I were to delete a cookie, for example? Our PHP session ID, delete. Now, suddenly, we have an undefined index error. This error is because we cannot +1 something that doesn't exist, doesn't have a value. So, this is what we need to do. To distinguish between whether a session is new or whether a session has continued from a previous session, we need an if statement that reads whether visits exist or not. So, if is set session at visits, then session at visits ++. Otherwise, initialize it to 1. Now, if we visit the website multiple times, delete the cookie, reload, we're back to 1 time, and you'll notice the cookie ID has changed. So, just to illustrate to you that this server does not know who this client is. If any server were to know who this client is, it would be XINF. They're running on the same machine, right? But let me take this session ID. Let's get a number here. Let's get a number like 20. I'm going to copy this session cookie string. There we go. Not enough characters if you ask me, but that's configurable. That's still quite a lot, but that's configurable. Pardon me. I can delete it, refresh. You can see that this is now a new session cookie. Right? It's a different code. If we re-enter the previous code, you can see that we return to our previous tally. Right? Does this make sense? Yeah? Good. Any questions?
You did like backspace, not the backspace, the back arrow. Does that use the same session key as well?
When I hit the back arrow?
Yeah.
I mean,
Like, you know how sometimes you want to go back to the page you were on
Oh.
previously? Does that use the same, key?
yes. So this thing is stored in memory. Basically this piece of information is persistent so long as you don't close the browser, right? In our case, hitting the back arrow will reload the same page, so the number will continue to go up even if I click back. Oh, except it's not registering. Okay, let me set that up. I clicked here a bunch of times. Hopefully that shows up in history. It does not. Oh. It would work if, like, the history is not counting page reloads as new page visits. If it did, then this would work. But, yeah. You'll notice that if I go back to a different page, then forward to this page again, my value is 26. If I take this URL, I open it up in a new tab, 27, right? If I have a new window, 28. If I go to Firefox, 1, right? Firefox isn't sharing memory with Chrome, so Firefox and Chrome are operating in different sessions. But that doesn't mean that we couldn't steal Firefox's session cookie and give it to Chrome or vice versa, right? Like, for example, if I take this session cookie, put it here, there you go, go back to Chrome, inspect, put the cookie in, there we go, oh, that's the same one, I want this one. Now I'm to 2. And now, because these two are sharing the same session cookie, three, 4, 5, 6, 7, 8. Right? But you have to, like, this only works because essentially I've, using Notepad and copy paste, I have hijacked the Firefox session from within Chrome. Does that make sense? Cool. Good question. Thank you. Any other questions about any of this? Cool. Right. So, this is actually, this information is old actually. Session destroy is now deprecated and not recommended. Session unset is the thing that you want to use now. So, essentially, I mentioned earlier that when you log out, what you're essentially doing is you're saying, hey, listen, server, I'd like you to take this session ID and just destroy all data associated with it. I want this to no longer be a session. Session unset is how that works, right? It doesn't remove that ID from the database, but having removed all data associated from it, it's as good as dead, right? There's no fundamental difference between an empty array and an array that, an empty array and a null array are basically the same array, right? From a practical standpoint. And session ID returns the ID for the session, which is useful for debugging purposes. If you want to work that into some kind of printed output statement, this information is also accessible from the developer tab. So, the actual session data itself is stored on disk by PHP between page requests, temporarily, typically in a /temp folder. This is a security risk on shared hosting. It's actually possible to implement sessions without cookies if you use sufficiently advanced get and post requests. Basically, if you use it in such a way that the post, any link that you click has a key value pair linking you to a session snuck in by the PHP. You can get there without cookies, but it is technically possible, but it's just kind of a lot of book work. It's a lot of bookkeeping, and like when you have the regular session mechanism available to you, there's really no point, right? So, good. Any questions? Okay. In that case, I think I'm going to call the break at this point. When we come back, we're going to take our login credential system that we used last week or the week before, whenever we made it, the database system that we were working up to do logins, logouts, registrations, that sort of thing. We will take that, we will add sessions so that it actually works as an actual credential system. Okay? Sound good? Any questions? Okie dokie. So, man, everybody looks tired today. I've heard there's a virus or something going around. Is that the case? Yeah, okay. Well, I hope everybody feels better as soon as possible. Okay, all right. I hereby declare half an hour break. Please be back here at 2:16. Thank you. Yeah. We were talking about you, Kevin. He doesn't watch the videos either. So, a little while ago, we were working on an example of a login credential system that used databases. So, we now have sessions as a practical example. Let's take our code that we were working on, integrate it with sessions so that we can get a login system that actually works. Our passwords will still be crap, but so it goes. Ooh, actually, before we get there, would you guys so as part of the curriculum last week, I showed a YouTube video on the subject of password cracking. If you haven't seen it, I highly recommend going in and viewing it. There was a follow-up to that video. It's about a 10-minute video, which I'd like to show you now before we get into the example. It's about how your password sucks and how to improve it. Pardon me. So we'll do that quickly, and then we'll get into the practical example. Okay? It's a video by my absolute favorite YouTube channel of all time, Computer File. If you want to endorse the channel, I'm totally open to that, just so you know. So, passwords, There you go, how to choose a password. It's actually 11 and a half minutes. For fear of copy strikes, I will now cease this video and resume when we resume. Go watch how to choose a password computer file. All right, so let's do this. Let's do this business. If you take a look in the announcements feed, let's go to today's code posted March 17th. There we go. That will be our password login system, I presume. Let's take a look. Yeah, there we go. So if you could please take the contents there, copy it into your htdocs folder, unpack it, and we'll see where we left off, shall we? And perhaps at the same time we could review MVC architecture, because I'm going to level with you cats and kittens. Sessions are not going to be adding that much. We can get pretty far without adding too many more lines of code. I would be surprised if we were about to add more than 10 lines of code to this. So, maybe we can do a running tally. Maybe that'd be fun. How many lines of code does it take to use sessions? So, question? Sorry? One? Well, I mean, use the session usefully, I should specify. So I just happen to already have it on my htdocs because, it was just already on the computer. So let's open all of this up, shall we? Open the files in your code editor of choice. Further, let's, just for completeness, what I'll do is I'm going to rename the folder. What am I going to do? I'm going to take the contents, copy it into this week's folder, make a new folder for it. I can just dump it in here, actually, that'll be fine. All right. Okay. We're good. So let's take a look at our controller. .php, connection failed, unlock, oh yes. So, I'll need to reinstate the database as well. This is why we test things. So taking a look at our model, we can see that the database name that we were using is login. Because this is occurring over XAMPP, our login credentials are root empty password. If this were any real system, not local to your own machine, you would have honest to goodness real credentials here. So, let's make a new database, call it login, create, give it a table, credentials, number of columns, 3. Let's give users an ID, make that auto incrementing. There we go. Username and password. Let's make those varchars of size 64. There we go. So far, so good. Create. Good. Now, going back to localhost, you can see our forms from previously. We have login, register, deregister. We have no users in the database, so let's register a couple of them quickly. Register user, Mr. Krabs, password is money. Boop. There we go. Register a user, SpongeBob, password is I'm ready. Thank you. And Patrick, password is password. There we go. Taking a look at our credentials table, we can see that all of our users are successfully registered. Yay! So, let's attempt logging. Mr. Krabs, money, log in. By the way, obviously if you're doing this for realsies, you will have this input as type password, which will give you the little asterisks over it automatically and typically won't save your information to your autocomplete. By the way, autocomplete itself can be a huge security vulnerability. If you accidentally enter your username into the password field and press enter, your form autocomplete will often save it. So that gets saved in plain text, so your password for whatever will be stored in plain text. Question?
I think I missed it. How did you connect your SQL database to the PHP network?
So, within the model, we have this code right here. We are creating a new PDO object connecting to localhost. This is XINF. Database's name is login credentials root MP password. If that connection succeeds, then it will proceed with the rest of the code. If it fails, then it will flunk out on an exception and print it. Is that what your question was?
So when I go into localhost, I should be opening that file first?
No, you should be loading the controller.php. You can see that the first thing that we do in controller.php is load the model. The model is not intended to have any code that just goes ahead and executes itself, aside from establishing the connection to the database, and as we are going to see, the session also belongs to the model. Management of interfacing with data storage is the responsibility of the model, not the controller. So all of the session stuff we're going to be doing will be in the model as well. Make sense? Any questions? So, MVC architecture. The controller, its main responsibilities, pulling inputs from the client, making sure they're good inputs, selecting which function in the model to run, and choosing a corresponding view. That is the responsibility of the controller. The responsibility of the model, running the quote-unquote business logic, talking to the file system, talking to the database, talking to the session. The responsibility of the views, dashboard is a view, displaying HTML, integrating values and variables from our PHP code into the HTML that we display to people. So, if we attempt login, we are given logged in, and we can see basically we have the worst website imaginable. Anybody who's logged in gets to see everybody else's username and password. Because we have no other data to work with just yet. So, the problem, of course, is that we can actually get there without any of this. Login.php, or what is it? Dashboard.php. So, although we are not usefully reading the table, we are also not, like we shouldn't be able to see even this, right? We shouldn't be able to see any of the dashboard if we're not logged in. But we don't have a concept of logged in yet. Even if we log in properly and then reload the page with no action supplied, you can see it, whoa, wait a second. Okay. If we do a login and then ask for dashboard.php, you can see we get the same thing. We don't yet recognize the existence of logins. So, for that, we will need a session. As I said previously, the purpose of the model is to handle communication with data storage. The session superglobal is a form of data storage. So, this is where we need to initialize our session. Session_start. Now, there are a couple of ways you can handle it. The naive or intuitive approach might be this. Well, a user who's not logged in should have no session, and a user who is logged in should be issued a session when they log in. Right? That makes sense. But here's the problem. It's actually a little bit, it's trickier than you think. It makes session management more complicated, right? We can use a simpler approach, always have a session established, but inside of the session superglobal, we simply keep a variable that tells us whether or not the person is logged in. This drastically reduces how much complexity there is in, is the session live, is it not live, should I establish it now, when should I disconnect it? If you just keep it running all the time, all you have to do is manage one Boolean variable to tell whether or not we're logged in. So, we have code down here. Oh wait, that was one line of code. So, we have a login function here. We can jump to it immediately because our model is well organized. All we're looking for is a function that says login, and we can just jump there and modify what we need in the login procedure. So, somebody give me the line number for the thing that executes if we log in successfully. What region of code is this? In this function, where should I insert something if I wanted to do something when we log in correctly?
In the if statement of success?
The if statement of success. Where specifically though? Give me a line number.
42.
42? Well,
Under 42?
so this just tells us if the database returned results for us, right? Essentially, we get here by default so long as the SQL query doesn't have syntax errors. This if statement is this, and this is not success as well. So on failure, but that's okay. This if statement is the one that's actually checking to see if the login succeeded, right? So it's actually right in here that we should be modifying the session. Session logged in, or perhaps we can say authenticated. That's too long. Logged in is fine. Logged in is true. So, now, there are certain things that we want to see and certain things we don't want to see based on whether we're logged in. Oh, and line of code number 2. Whether or not we are logged in has an effect on which page we see. It's part of the decision logic for which view is presented. What part decides which view is presented? What file am I looking in?
Controller?
The controller. That's right. So in the controller, we scroll down to the part where we're deciding which view is seen. If is set TPL logged in, we want to display the dashboard. Now, as a matter of fact, storing this information in the TPL is no longer useful. We have the session for this now. The session is more persistent. So I would even say that we should replace TPL template array with session. There we go. And since we no longer have any use for it, we can delete the line of code where we had the TPL previously. So, there we have it, logged in. Line of code number 3. So now, if we go to the controller, there we go, and we log in, undefined index credentials table. Let's see, what did I do? Oh, you have to change it here as well. This is where we determine if this was a successful login attempt, in which case we get the credentials table. So let's save that, refresh, there we go. We are logged in. However, we have a bit of a problem. If we access the controller now, it does bring us to the login page because it detects that we are logged in according to the session, but it still does not load the credentials table. The data access previously, we stuck that inside of our switch controller, so it only goes to load the credentials table if a login attempt is made. But this is not true. We actually need that data anytime we try to load the dashboard. So it no longer makes sense to have this up here. We should get the credentials table immediately before showing the dashboard. So that was add 1 line of code and remove 3. So if we try this again, now even though we are not, so recall that we left this in to see like what the parameters are that we're sending. We're not sending any parameters, right? We're not making a login attempt. All we are doing is accessing the controller, and it is giving us the the page we see when we're logged in. Make sense? So far so good? So, so far so good. If we have the ability to log in, we should have the ability to log out. We need to add a new function to the controller. Let's do this from the start with the view, step through to the controller, and then put that functionality into the model. So, on the dashboard, what we want is a log out button. We can put that perhaps right here. Oh, just to make it, I'm going to do it with a link. There we go. Let's take a look at how this works. So, I have linked the text logout back to the controller with query parameter action gets logout. This is currently an unsupported action. So, refresh the page, we now get a logout link. Click. We can see that action logout has been sent, but again, we have no code that handles it, so we are defaulting to the dashboard view. So, let's now head back to our controller. Now, ordinarily, for a logout system, you don't require any additional information from the user, right? You don't have to re-enter your username and password just to log out of a login system. That's not usually how it works. So we don't require anything other than action logout in terms of parameters. So, controller, let's remind ourselves of the structure of our switch controller. We are reading the action in, filtering things in the usual manner. If action is null, then we skip it. Otherwise, we switch on the action. We've got a case for register, deregister, and log in. We can, most of this code is due to the fact that these are operations that could fail, right? By the way, how could a logout fail? Any idea? If you weren't logged in to begin with. Or if you've invalidated your session cookie. That's another way of doing it. Case. Log out. since this is the thing we're doing, we're having it echo back what the operation what we're attempting. We need to, we don't need to check to see if user and password are null because we do not intend to receive them. And even if they're provided, we don't care. So we can skip straight to log out. And we don't have to pass it anything. Great. Simple. So, let's see here. We added one line here, and we added 4 lines to the controller. Okay, I'm beginning to think I might have been a little bit, 10. But come on, those are pretty short lines of code. And one of them is an echo statement. I'm taking the echo statement off. That one doesn't count. So let's add a new function. Function log out. There we go. So for logout, we are really only connecting to the session. We don't need the database connection, although it might be useful to have the this guy. Next, we unset the session. This clears all information contained in the session superglobal. This actually returns its return result is the success or failure of the operation. So we can store that in the TPL. If success is true, then the error will be not true. And I suppose we need an error message. I was trying to do it fancy, but okay. I'll follow the previous form. 15. It'll be under 15 lines of code. Unknown session error. Here we go. All right. 1, 2, 3, 4, 5, 6. I don't count those. 1, 2, 6. See. Now. Unknown session error. Okay, let's try logging in. Log in, there we go, log out. Interesting. Well, time to start debugging. So, success. Oh, well there it is, actually. Forgot to remove that. You guys know what that does?
Delete everything.
No, the exclamation point.
Oh.
It makes it so it doesn't run.
Yeah, it takes true, turns it to false, takes false, turns it to true. That's Boolean not. So, there we go. Try that again. I log in. I'm logged in, I log out, I'm logged out. Ta-da! And now we have a functional login system. Any questions? Okay, under 15 lines of code. So, since we have a little time, let's talk about password hashing. This is also something that's very important to know if you're going to actually work with these systems practically. So, although it doesn't appear in the notes, let me check to see. Let me just check to make sure. I think that there's only like, we just had the one slide set, but let me just make sure. Yes. Good. Yeah, we'll save it for next week. So, yeah, we'll save password hashing for next week. So, good. I would like to now set everybody for the remainder of class. I'd like to set you guys an exercise. So, if you can please open up a new PHP script, that would be fan-flipping-tastic. If you go to the Assignments tab, oh, that's for user authentication. All right. Never mind. Not the Assignments tab. If you look at the board, this is what we're going to do. So, I would like you to write for me a system using sessions which does the following. HTML page should have a form input for an integer use sessions to calculate the average of all, oh, you'll need a submit button too. Use sessions to calculate the average of all numbers the user has entered into the form. Does that make sense? So essentially, you will have an extremely simple website. It'll look like this. Something like that. Make sense? So,
So it should ask for a number, then calculate the average. It should ask for two numbers and add them.
nope. Each time you reload the page, it takes this number and adds it to the session in such a way that you get an average. So like on the first load of the page, if you enter 2, it stores 2 in the session. On the next load, if you do 4, it'll calculate 2 plus 4 divided by 2. If you add another one, 2 plus 4 plus 6 divided by 3, etc. That's what it's intended to do. Does that make sense? Okay. Good. It's exactly 10 if I subtract the 3 lines that I took away and then don't include the break statement. Because it's basically the same thing as a closing curly brace, come on. Oh, it's in full screen mode. There you go. Okay,
which is again fine.
yeah. see, colon 1080.
Oh.
And select whatever the file name was that you picked. Test, so enter test where dashboard is. There you go. These are two separate questions, by the way. I should have said that. Back to that website.
What is this?
No,
Okay.
it's doing too much work. To calculate an average, you only need two numbers, right? The number of numbers and the sum of those numbers. You don't have to store the numbers in an array,
Okay.
right? So as long as you keep a running sum and a running tally of how many numbers have been entered, then you can calculate the average. There's question 1 for you. There's question 2. Right now, everybody's working on question 1. And there's that other board. Doesn't really have much on it. There you go. I didn't publish the room for the exam, did I? No. They need to get me that. It's getting close. Always a scramble at the end of the semester. Okay guys, you want to see the solution? Or a solution anyway? Let me just fix the camera. I didn't forget about all you listeners out there in TV land. So this one is a sort of reasonable extension of the site counter. You can take the site counter and turn it into this one. Save as session average, there we go, .php. So we want the form action will be session average.php. Input type is equal to text. You can put number here. In fact, why don't we do that? Number. Type is number, or is it numeric? I forget. Is it numeric?
Number.
Number, okay, thank you. Name is, let's just call it num. Input type is submit. Value is equal to calc average. There we go. And of course, let's throw a little running average is echo. Let's create an average variable that we haven't populated yet. So, basically, this is how we will treat it. If we have received a number, we will treat that as form submission. If we do not receive a number, we will treat that as nothing has been modified, so the average should not change. But first we need to read to see if we get the number. Num is equal to filter input underscore get, there we go. Name is num. And this is an integer, well, it doesn't have to be, you could also do floats, but I'm going to do integer because integers. Filter, validate, int. So now, if we get a false or a null, those are both error states that mean we don't update the count. Right? So, if num is triple equals to null, or num is triple equals to false, we must use triple equals in this case because 0 is a valid value, right? If num is false or null, then we basically, let's just do what we were doing before, or do nothing. Otherwise, there we go. This is the branch where we do the counting. Now, I'm going to do things in a slightly more compact notation using ternary. Session at sum equals, is it set? If so, then we want to do its own value plus whatever num is. Otherwise, 0, which will initialize it. Does that make sense? I can do that as an if statement if you want. Would you prefer an if statement? Yeah, okay. I'll tell you what, I'll do the next one as an if statement. If is set session at count. Session at count plus plus, add 1 more added to the count. Otherwise, we want to initialize it to 0. These two ways of expressing things are actually precisely equal to each other. That is the same logic. So you can see you can do things a little more compactly than perhaps you thought you might be able to. The use of ternary here absolutely hinges on the fact that in both cases we are assigning to the same variable. So we can take that and extract that detail out, or abstract that detail out. So, good. Now, we just have to calculate, oh, the average. Well, session count should not initialize to 0, it should initialize to 1. Otherwise, we're going to end up with a 0 division error, which would be silly. So, as we all know, average is equal to this guy divided by that guy. And now, if we reload the page, I think I called that session average, right? Oh, undefined index. Oh, yeah. Sorry, you want to put this in the else case. There we go. Undefined error, okay. So to solve this final error, which I believe will be the final error. Where's the, not there. Nope. Here. Where is it? Let's load it up again. There we go. So the thing it's complaining about here is basically, I haven't calculated an average, but I'm still asking for the average. So, we have two ways of going about this. Either we register it to the session, or we exclude this piece of code if the average has not been calculated. Since this is the class on sessions, why don't we go with that first one? Session at average. And that way, we can just pull from the session directly. There we go. Except it's still not set. So we have to do that anyway. Let's write a little PHP. Oh wow, time is running short. Here, I'll just show you it works. 5, 5, 5, 5, 9, 10. You can see it's running, it's calculating the average, right? Make sense? Aside from that bug, which you could fix with an if statement, excluding this phrase if the average doesn't exist yet, that's a solution. Any questions? All right, well, in that case, I hereby dismiss class. Thank you very much for your time and attention. I will post the code as always.